1017 convert to base -2. Yeah, so we are giving an integer n, and this integer n can be any numbers from more than or equal to 0, less than or equal to 10 to the power of 9. And we're going to return a binary string representing its representation in base -2. Yeah, so note that the returned string should not have leading zeros unless the string is 0. So this means the final result should not have any leading zeros. So for example, the result is 110. It cannot be like 0, 110 because there's no leading zeros. And for this example, it is 100, and for this example, it is 111. Yeah. So let's first try to understand all the examples. So for the first one, it is 110. Why it is 110? Because -2 to the power of 2 plus -2 to the power of 1. Yeah, because this is at position 1, and we're gonna plus another one because it is a 0. So 0 it is okay. 0 times -2 to the power of 0. So this is 1 times 0. This is 0. So it is not written, but it should be like that. Yeah. And for this one, it's going to be -4, and this one going to be +4, and this one going to be -2. So the final answer is going to be +2. So for n equal to 2, the base -2 representation going to be 110, and similarly for this 3, actually it's going to be 111 because here is 4 minus 2, here plus 1, so the final answer is going to be 3. And for this example, yeah, so it's going to be directly -2 to the power of 2 because this is a 0, 0, it doesn't matter. So the final answer is 4. So how can we solve this problem easily? And if this is a base 2, normally it's going to be easy. So for example, we're going to use an example of 6 divided by 2. So what's going to happen? Yeah, so what if we just convert it to base 2? So it's going to be easy instead of a -2. Yeah, so if we're going to convert it to base 2, so this is a 6 divided by 2. So we're going to what left behind 6 divided by 2, so it's going to be 3, and the remainder going to be 0 because the 6 can divided by 2, so the remainder going to be 0. So this is the remainder. Now we're going to continue. So what about 3 divided by 2? So 3 divided by 2, yeah, so the result is going to be 1, and the divisor going to be 1, and the remainder is going to be 1 as well. Now what's going to be 1 divided by 2? So the divisor is going to be 0, and the remainder is going to be 1. It's going to be itself. So this is for a +2 base 2 case instead of -2. So the final answer, instead of 0, 1, 1, we're going to reverse it. It's going to be 1, 1, 0. Yeah. Now let's just try the negative calculation. So what if it is a negative value? So we're going to use the second example. So if it is a 3 divided by -2, so what's going to happen? So first of all, we need to check the result. So 3 divided by -2, normally it's going to be -1.5, right? Yeah, but we cannot have the decimal values. We only need to have the integer. So if we were to have the integer, of course, here going to be, let's see, so here going to be -1. Yeah, because this is a -1.5, so definitely we need to have the integer. So instead of a -1.5, we need to have an integer of -1. So what's going to be the remainder? The remainder is going to be -1 times -2. It is a 2. So 2 plus 1 going to be 3. So the remainder is going to be 1. So this is going to be, yeah, the remainder. Now we're going to continue. So this is a -1 divided by -2. So what happens for this case is that because -1 is a small value, so the divisor going to be 0 because it is too small. So what is left behind is -1. Yeah, because definitely -1 is too small for this -2. Yeah, it is similar like 1 divided by 2, but here is -1 divided by -2 because it is too small. So the divisor is going to be 0 and the remainder is going to be -1. So the final result is going to be -1 and 1. But in the binary representation, there's no -1. It must be 0 and 1. So we should not have this -1. So instead of having this -1, so we're going to change it to a positive value. So will we change it to a positive 1 or will we change it to a 0? Definitely we cannot change it to a 0 because if it is a 0, it is nothing. So we need to change it to a positive 1. So what happens if we change it to a positive 1? So here, before it is a -1. Now we change this to a positive 1. So what happens? Now this is a -1 divided by -2, and the remainder from the -1 becomes the positive 1. Yeah. So this means from the -1 we need to plus a 2 to let it become positive 1. So it means the -1 gonna plus a 2. So similarly for the final result, for the final answer, yeah. So before it is a -1 divided by -2, so the remainder gonna be 0. Now instead of a 0, so here it's gonna be a 0 plus 1. So this one gonna be 1. Maybe this is confusing. Let's just do some calculations, and maybe it's gonna be much clearer. Yeah, because here we're gonna plus a 2. It means from yeah, because of here we're gonna plus a 2 to let it become a 1. So from here we need to plus a 1 because this is the divisor, because it has already divided by -2. Now let's just use an example maybe. So before, instead of 0, so let's just set this value to x, right? So as this is x and this is -1 divided by -2, so this means -2 times x, -2 times x, and the remainder gonna be -1. So this is the remainder, and the answer gonna be this one. It's gonna be this -1. So this is the calculation. Now, instead of using this -1, currently we're gonna use this positive 1. So if we wanna use the positive 1, what's gonna happen is here. Before it is a -1. Now it's gonna be a +1. And if this +1, it means it's gonna plus a 2. And now from here, it's gonna minus a 2. So this means minus 2x gonna minus a 2 plus 1. And then it's gonna equal to a -1. And then we're gonna take out this -2. If we take out this -2, so it's gonna be x plus 1. And here we're gonna plus a 1 to the -1. So what happens for this x? Before it is just x, now it's gonna become x plus 1. So before this is 0, now this is gonna become 1. Yeah, this is a little bit mathematical calculation, and we need to understand about it, otherwise we cannot solve the problem, you know. Yeah. So this is a -2 times x plus 1, and from here this is a -2 times x, and this is a +1, this is a +1 as well, and this is -1, and this is -1 as well. Yeah. So this means for this calculation, if we were to use this positive 1, it means from here, if we were to use a positive 1, yeah, let me just clean up a little bit, and this is a 0. If we were to use a positive 1, from -1 we're going to change it to positive 1. So what happens for here? The final this -1, it's the same from here, -1, but this x is going to become x plus 1. So before it is a 0, now it's going to become 0 plus 1. So if it is a 0 plus 1, so it's going to become a 1. Yeah. Now let's just do the calculation. So 1 times -2, it is -2, -2 plus a 1. So it's going to become a -1. So this means our calculation is right. So now let me just clean up a little bit for here. Yeah, now let's just continue the calculation. Now the positive 1 divided by -2. So as it is too small, so the final result, so from here it's going to be 0, and the remainder going to be just this value 1. Yeah, because 0 times -2, it's going to become 0 plus 1 here, it's going to become 1. Yeah. Now what is the final answer? It is 1, 1, 1. So this means for this number 3, the binary representation is a string of 1, 1, 1, and this is our calculation. Yeah. Now we just need to turn such kind of calculation from here into the coding, and then we're gonna directly use the coding to solve the problem. Yeah. So it is just a binary calculation, but instead of a positive 2, now it becomes a negative 2. But what if we find a value, the mod? So yeah, so what if the mod from here, for example, before it is a negative 1, we're gonna turn it to a positive 1. So if we turn it to a positive 1, so from before, this value, for example, it is x, and we need to plus 1, it's gonna be x plus 1 from here. Yeah, so this is all the calculation about it. Now let's just start coding. Actually, the coding gonna be much easier if we understand all the calculations. We're gonna take this number while this number is more than 0. So we're gonna do the diff mod calculation. So this number gonna be n, and we're gonna prepare a mod. It's gonna be the diff mod of this number with a negative 2. And the final answer, as I said before, it's gonna be a reverse. It means the result gonna equal to string of the mod plus the final result, and this mod gonna be m, and the result gonna be this result. And finally, we're gonna return the answer result if it is a result, if it is not empty. But what if it is empty? We're gonna return a string of 0. Yeah, because if this number, for example, this n is 2, but what if this n is 0? If this n is 0, definitely we're gonna return a string of 0. So instead of empty, this is according to the problem. If you forget about it, you're gonna get a wrong testing case. Instead of avoiding that, so if this number is 0, so we're gonna return a string 0 instead of an empty string, because this has more meaning. Yeah. Now from here, as I said before, what if this mod gonna equal to a negative 1? So the first step is that we're gonna turn this mod to a positive 1, and also we're gonna updating the value of x. So here this x is n, so n gonna plus equal to 1. Yeah. And now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast. And the time complexity is just log n. N is 10 to the power of 9. So why I'm gonna try to posting this problem in YouTube videos, because I tried to search it and didn't find it. So yeah, so I would like to put it in a YouTube video and let us learn about the easiest way to solve this problem is just by using mathematical calculations. I think that's all about it. Thanks for watching. See you next time.